Owners of sliding table saws often face the same problem: how to cut a thin strip or a small piece of a compact workpiece quickly, accurately, and safely. On the left, the crosscut fence scale usually only starts 15 to 20 centimeters away from the blade. On the right, the rip fence is set back to prevent kickback, making it impossible to pass a short workpiece through the way you normally would on a cabinet saw. If your saw is equipped with a digital readout, working with small parts becomes even trickier. Due to the physical size of the digital stop housing, it cannot be moved close to the saw blade. Accurate digital measurements only start past 320 millimeters. Anything under 32 centimeters falls right into the fence's blind spot. The Fritz Franz Jig is designed for this exact purpose. It allows sliding saw owners to handle these tasks with pinpoint precision by clamping the workpiece securely to the slider and keeping hands well clear of the danger zone. It's an extremely useful piece of kit, and I really felt the lack of it. I specifically made time today to build it. But before starting, I checked the cross-cut fence for 90 degrees using the 5-cut method. After some fine-tuning, I got an almost flawless result. The total error on the 5th cut was just a few hundredths of a millimeter. From a leftover piece of thick MDF, I cut 2 blanks for the future jig. Unfortunately, I didn't have any composite material on hand, so I made the miter bars for the sliding table slots out of birch plywood that had been sitting in my garage for over 10 years, so it definitely won't work. Using a dado blade, I cut the groove for this bar. As you can see, everything fits super snug and very accurately. My saw came with an edging shoe for the sliding table. I'll be using the locking handle from it to secure the jig in the track. This exact handle will allow me to lock one part of the jig onto the sliding table. I'm cutting the 1 meter aluminum track with scale in half for the 2 parts of the jig. I originally bought fine-tuning stops, but once they arrived, I realized that version wouldn't work here. So, on AliExpress, I ordered a high-quality aluminum track with a steel tape measure and rock-solid flip stops that feature their own micro-adjustments. I also have a micro jig push block from which I plan to steal a handle for the second half. Plus, courtesy of my home experimenters, I ended up with a piece of aluminum profile I thought about using to mount it. However, after thinking it over, I realized this whole setup would not only look horrific, but would also be clunky to use. So, I took a different way. I set the required width and cut the grooves on the bases for the perpendicular stop tracks. For the fence stops themselves, I'm using a glued up block made of dry oak offcuts. Once the birch guide bars are glued to the bottom of both bases, I place them on the slider and make a cut. This cut perfectly calibrates my Fritz and Franz relative to the saw blade. I'll cut off the excess at a 4-5 degree angle to make the jig more comfortable to use. Now it's time to screw down the glued fence and attach the aluminum track with the tape measure and stop block on top. It's time to make a handle for the second part of the jig. For this, I'll drill a hole in the base and I'll turn the handle itself on the lathe a bit later. Next, I screw on the aluminum track with the stop. I'm turning a comfortable little handle out of a small piece of mulberry. I didn't have a 12mm drill bit on hand, so I had to use a router bit to make the hole for the threaded insert. I glue the insert into the handle using CA glue and finish the handle itself with linseed oil. Well, it's time to install the jig, make a few test cuts, and calibrate the scales. As you can see, with this jig, I can easily, quickly, and safely cut small, narrow workpieces to any size, both rip and crosscut. Now it's time to set the accuracy of the scale. To do this, I cut a small sample piece, measure it with a caliper, and adjust the position using the micro adjuster. After spending 10 minutes testing and fine-tuning, I managed to dial in an error of just a couple hundredths of a millimeter. I call that a success. Having spent a good amount of time building this jig, I can confidently say it's exceptionally accurate, convenient, and safe for working with small workpieces.